Welcome to the extra exercises of lesson 3. If we have to use Prim's algorithm, it means that we have to start with the smallest edge, with the edge with the lowest weight. So that would be this edge. So we start from C and we connect F. And then from one of the points, either from C or from F, we'll try to find an edge again with the lowest weight. And then the candidate would be this one, from C to H. Okay, let's do that one. And then again, we have to look for an edge which is connected to C, H, or F with the lowest weight, which doesn't make a circle. So from C we can do 8, 8, and 5. And the other one's H is also a 5, but that makes a connection. Okay, then this would be the edge, which is with the lowest weight, which doesn't make a cycle. Okay, then again, we have the next one. We have a 7, which is small, and a 5 here. This one is the smallest. Okay, then we have a 5 here, which makes a cycle, but we have a 6, which connects E. Now we even have a 3 option. That's lovely. So that's this edge. Okay, then the smallest one available is this 5. Connects D. And I think we have all of them now, huh? Yeah, so this would be the minimum spanning tree according to Prim. In the next exercise, they want us to find a path from D to B with the help of Dijkstra. And we're going to use a table just as you would have to do on the exam. So what we'll do is we'll start at D. So we start at D and then we'll just consider all outgoing edges from D. So we have an edge of length 8 going to C. So that's 8 D. We have an edge 7 going to G. We have an edge 9 going to H. We have an edge 3 going to E. And we have an edge 6 going to A. And I've made a dash through them, so we don't need to consider these edges anymore. We've done them. And then in the next iteration, Dijkstra says just choose the one with the smallest number so far, and that is this one, 3D. And from this one we try to work our way into the direction of our endpoint. So we have E, and so far the size is 3. Now let's see how far we can get from E. So we can go to B immediately. That's nice. So we'll already have a path to our end. So that's 3 plus 6, that's 9. So coming from E with 9, and I'll circle it because this is already an end path. Then let's see if we can find something smaller. So from E we can also go to G with 7. Okay, that's too much because we already have a shorter one there. From E we can go to A with 5. Again, we already have 6 there, so that's too large. And from E we can go, oh, that's it. So let's reconsider. So we have a 6, an 8, and a 9. And because we already have a path length 9, we don't have to consider this one anymore, because it can only become larger, not shorter. So we have 6, 8, 7. So we do 6A. So from A we can go, there's A, yeah. From A we can go to H with 7. We have A, total length 6. And the 7 is 13. And that is already much too much. Anything above 9 I don't need to consider anymore. So from A to B, 7, too much. 9, too much. So everything which is larger than 3 doesn't need to be considered anymore. So this one is done. Okay, what is the smallest now, which could still give us a good path? Yeah, maybe G then. So let's look at this one. Do I have a path out of G which is 1? Because that's the only one who's going to replace my length shortest path of 9 so far. Well, from G I don't have any 1s. So in fact we're done. And so the algorithm leads us to the path which, if we backtrack, we are in B, and from B we go to E, and from B, E we had D. And in total this would give us D to E 3, and from E to B 6. So our total length is 9, the shortest path from D to B. Oh, this was a small one, huh? We only needed 4 iterations. That's not bad. Then the last exercise, find all spanning trees of this graph. Okay, let's give it a go. So we start from A, and then we can do B, C, D. That's one. Let's start from A again. Can do B, C, and D. That's 2. Start from A again. We can do B, C, and then from B go to D. Okay. Then the next one. We can go from A. We take D, and C, and B. A, D, B, C. A, B, D, C, A, D, B, and C. And the last possible one is A, B, D, C. Okay, those were the extra assignments of week 3, and let's move on to week 4.